So hello, this is the second tutorial of this Grasshopper tutorials series for Studio. Today we're going to work from Windows because we already saw in the last tutorial basically like the main differences between a Mac interface and a Windows interface. So basically what you have on the Windows side as a set of buttons and also tabs to do a lot of things you can do, of course. Also on the Windows side, the main difference is that instead of having like the optical snaps on this side of the screen on Mac, you have them here on Windows. But basically, everything works pretty much the same. Also, like maximizing a viewport, rotating, panning, relocating your gimbal, and so on. So we will launch Grasshopper. You can write Grasshopper on your terminal here, or just click this button. And what we will do today is to understand a little bit of basically data structures. So as you saw in class with Professor Killian's example, you can, for example, have a line, right? Or two lines. In this case, remember, these are curves. So I am going to reference these curves. Set one curve. Set one curve. So basically I have two curves. I'm not gonna use this for now, so probably I should hide them. I'm gonna put Grasshopper on this side of the screen so you can see what I'm doing. And in this case, I'm going to divide these curves into segments. So if I want to do that, for example, I use this node that you can find because it is related to dividing a curve. You can find it here, curve. And you can go to, it's util, no, it's here in division, sorry. You can divide in equal segments a curve according to its length. So in this case, I am going to use two of these nodes. Sometimes you will find that it's good to only have one node, but this is a more advanced Grasshopper manipulation that we can see in another tutorial. So you always need to understand what a node is. In this case, this is a function compiled inside a node that takes input arguments and basically it spits or basically gives you back, return a set of transformed data. In this case, basically it asks you for a curve to divide. It asks you for a number of segments. So basically it will divide the length of that curve into segments, equal segments according to this number. And basically here, if you have a curve that has a discontinuity, basically a kink, you can split this curve and divide all those segments according to starting from those kinks. And this will return your division points. It will return the tangent at that point, and it will return also the parameters, basically a list of the parameter t, basically the where on this local domain of the curve the point is. We will see that in a minute. So for this we need to basically get a slider, because this is an optional parameter. There's an optional parameter in the constructor of this class, because basically this is a class object, curve. So we can, these are some tricks that I will show you now, very briefly. If you want an integer number, you can, integer number slider, you can double click and, for example, write 10 and press enter. And this immediately will create a slider from 0 to 10 without going to parameters, slider, creating a slider, right click on the name or double click on the name, setting this to an integer like n, and specifying that the maximum value that you can get from here is 10, approving the changes and doing this. You see, it's a more fast and direct way of doing this. So, for example, if you want a slider that has like decimal numbers, you just write 10.0 and you will get the same slider, the same domain, but you will have decimal numbers. I haven't tried this, but let me check. If you write 10.000, you will get a slider with a precision of 3 decimal numbers. Also, in case you didn't know, when you move the slider but you press Ctrl at the same time, you can have a more smooth transition between values. Let's say I want a slider that takes number from -10 to 10. You do this: 0, 10, -10, less than 0, less than 10, and you will get a slider between -10 and 10. You do the same with decimal numbers. So pretty easy, pretty direct. This will save you seconds that will turn into minutes if you're performing this operation many times when you work, and make your workflow more efficient. So now I am going to create a slider with, for example, 10 divisions, and I will use 10 divisions for this node here and this node here. So basically I always want to be like really organized with my things. So I will plug this curve, so you will see by default this node has data in it, internalized. Remember this from the previous tutorial. It always comes with a 10. So if you plug this curve, it will have 10 divisions. Now, if I plug my slider with the number 10, of course it will remain the same, but now I can parametrically perform a change in that. So now what we have here, we have something. If we check the output from these nodes, we have a list of points, and again, just as processing in like regular programming, these are always zero-based lists. So what you see here in the panel that basically lets you visualize the data, you have at the 0 slot, let's say, of this list, the 0 element of this list is a vector, and you have basically 11 numbers here. We'll say why? Because basically you are dividing with 10 points, and you're getting getting 10 divisions, so you're getting you need 11 points for that. At the same time, you are getting the tangent of to this curve at each point, and you can see that now this is the same vector because we're not dividing by like any strange curve, so the tangent is always pointing in the same direction. And this is interesting, we have the here, and this is something that also you need to remember because this will be very important in the future for more complex operations. Here you have the t parameter, like small caps t, and basically you will have the t parameter of each of these points. And you can see that, what does this mean? If we check the length of this curve, I will write here length, get this parameter, this thing, and if I get the length of the curve, I will put this panel here. Basically you see that the length of the curve is 29.94485, and you will see that basically this is indicating where, according to a measurement in this curve, according to the length, is each point located. So you see like 0, 2.99 something, and whatever. And this could be very useful for some operations, but sometimes you just want to get a proportion, a ratio of the length related to the point. So for that, if you right-click on the C input of the node, you will have an option that is called reparameterize. So basically you will express the domain of the curve between 0 and 1. So check what will happen now that I will click on reparameterize. Now this changed in terms of the percentage of the length where the point is on this curve. So you will see that because these are equal length, you have one at the 0% of the length, 10%, 20%, and so on. And this is really useful because basically now you can divide and locate a point without basically, for example, if I show my curves and if I change the length, you see, I changed the length of this curve. Actually, I should change this one because this one is the one that I have plugged to the panels. I can change the length of this line, of this curve, but these parameters never change. On the other hand, if I don't reparameterize, I can basically move this, and these numbers should change. They didn't. Because basically this is just like the this is where white didn't change, but that's okay. But basically, I mean, what you need to know is that if you reparameterize, you will get always the same proportion of the line, and that is really cool to perform certain operations. So, and I will explain later why. So now we have two data structures. So I will also reparameterize this. Oh, actually, we should do something to understand the difference. No, we will do it later instead. So we will reparameterize this one. We will delete this component here. And we will create a line between this component and this component. So basically to that, we can go to curve. We have line, because basically this is an object that only takes one point, one start point, and one end point, and gives you a line segment. So we will connect the start points. Basically this curve will represent all of our start points, and this will basically represent our endpoints. So we'll connect this, and we have, of course, like this structure. So also, if you are really new to Grasshopper, you can basically start doing things like this, organizing your graph. You can always put, for example, a panel here, and you can double click and say, these are my parameters. Cool. Then you can basically copy and paste this, and you can say that these are my, I don't know, step 2, for example. Divide curves in equal segments. Segments. And then, for example, you can say here, this is step 3, for example, create a line connecting, create connecting lines. So in this way, when you add these messages in this way, you can help other persons and even us to understand what is your basically workflow. And this is really cool because also I will explain this instead of like doing like a super complex shape. I want you to understand in the first 2 or 3 tutorials how to work in a better way with Grasshopper. I mentioned in the previous tutorial that this is really cool because you're not destructing your data. What does that mean? So for example, here we created a line. That's awesome. But we can also use these points to do other stuff. For example, I don't know why would you want to do this, but I can say, oh, I also want to create a circle from this point. So you can do that. You can connect this, and this will create a circle, basically another curve that you can specify a radius. So for example, you can say, oh, I want point, let's say 5.0, and you can create, sorry, I connected to the wrong thing, so I disconnected pressing Ctrl and making the connection again. The radius here, I can modify it by doing this. Pretty simple, pretty straightforward, but this basically shows you that once I perform this operation, always the data stays here, so I can use it again to do something else. Why I mention this? Because you might want to do the same thing modeling and you will lose all the references. So we'll erase this because we don't need it anymore. Another way of organizing your data is creating groups. For example, I can select this, right click in the canvas, and I can say group, and you will create a group that you can also, if you right click inside this area, now that is color, you can name it. For example, one, set parameters. Excellent. And you can basically get rid of these panels, and this looks like a little bit like I don't know, clean. So you can also like group this, and you can say that this is your step 2. Dividing lines. Awesome. And then, and so on and so forth. If you want to add, for example, I can say this is divide lines and create new segments, or connecting or creating connections. But you see that this element is not part of this group. You can always select the group, select this, and how do you add it? I think you do this. Add to group. You right click, add to group, and basically you have this. You can always change the color of the group. So for example, you can order, or you can organize your definitions. For example, say that always purple will be parameter related groups. Red, for example, or another color, blue, will be always related to modifying operations, such as like dividing something. And maybe like yellow will be always related to creating new things. So that's also a way to create your own language, to do stuff in Grasshopper, and again increase the legibility. For now, we will forget about groups, because I want to show you also something that is very important. Now we have the equal set of divisions. But also you will notice something that we didn't see in the previous tutorial, and probably because you have played with Grasshopper, you realize by working with it. We have this type of line, and this is actually quite odd. Basically, we have this type of line that is just a single dark gray line, and from here we have something that looks like thicker, like a double line, basically something that is like, I don't know, like a thicker cable. What does this mean? So basically here you see that from this node we're always having one parameter. Basically it's only one data point, one data vector or whatever. From here we're getting one integer, right? It's like one value, 10, but it's only one data point. Same here. So this is like a thin cable. But from here, you see that we have a list. Basically, we're returning 10 points. So basically, it's like more data. And you will always know the difference when you're getting like multiple things, because you will see this guy here. Now, if I do this, whoa, what happened? Basically, I use graphed, and something really cool, but also sometimes dangerous will happen. Now, basically, we are returning not one list. I will show you the difference with a panel so you can understand. You can see it here. And also, you can see it here. What is the difference? Basically, when you graph something, you are dividing a list. In this case, we had, like the original was this one list with 11 division points. When we graphed, and you can see that this is a list, basically with 11 elements, you graph basically from this single list, you create 11 lists with only one component. And also, you can see that the data structure changed completely. What is your data structure? Of course, like one list, 11 lists, but also is the tree structure change. Here, this is our tree structure. Basically, you're saying that you have one tree with one branch, and inside this branch, you have all of this data. Now, we have basically like one tree, another branch, and now branch 0, 1, blah, blah, blah. And now you can see that also the wire change, and basically now this is like a dash wire, and that's an indication that this contains many lists. You're transmitting not one list with many elements, but multiple lists with n number of elements. And why do I say that it's really important when you basically realize or you play with these things? Because now we basically are creating not 11 lines as before, but we're creating 121 lines. So imagine if you have like a lot of divisions. You will create a lot of objects that will live in your RAM memory, and if you're not careful, you probably will crash Grasshopper, or your computer will get like super slow. So again, I need to mention, each time that you say like, oh, this must be cool to do, or I will try something new, but I don't know exactly what will happen, save. This is your best friend. Even though Grasshopper saves a backup file, you will lose information no matter what. So you save this and you will be safe. So again, let's explain also what happened here. But basically you divide this list in many lists. You have other options. So for example, if I don't do the graph, but basically I reverse the list, you can see that this is pretty logical. Basically, you're reversing the order of the points in a list. So now the first point, assuming that this is the first, will connect with the first of the other one that now is here and not here, because you reverse the points. So basically, you create these connections. Flatten, I will explain later. You can simplify also to basically simplify the tree structure. So again, if you want to visualize how this looks, you can have the parameter viewer. Here you have data with one branch, and here you visualize in a more graphic, not numerical way, what's happening here. So I will duplicate this guy. This is really good for understanding what is going on. So now we have this here, but for example, if I graphed this list, You see what happened? I have 11 branches with 11 elements. So your data structure changes. And basically this is a really neat and cool visualization because it allows you to understand that basically this is like water or like electricity flowing through a circuit. Basically with each function you're just like channeling or deviating in a different way this flow, right? So here it always follows this because it's just one list, and here basically you're creating like new parallel branches that you can work separately. I hope you understand that. That's really cool. We're gonna go back to the simpler example. So now we have just two lists. What happens now if I, for example, decrease the numbers of connections to 5 on the second list? Basically the matching between two lists creates this type of weird figure. Basically this is the let me check because it used to have like the cross reference. It used to be integrated here in the node, but now they change it here, and we will see what that means. Basically you're creating a cross reference between two lists, right? So basically what is going on is that basically you have the first element connected to the first element of the second list, the second to the second, the third to the third, and so on. But basically when you reach the sixth point of this list, you don't have any other elements to match the following ones, right? You run out of points on the second list. So basically Grasshopper by default will create this cross-reference, basically connecting all the remaining points to the last one. Sometimes you want that, sometimes you don't want that. So this functionality that used to be integrated here, now you have it here. So for example, you get the first list, you get the second list, and you connect this to your points. And this is to create, for example, a different type of cross-references. Oh, probably this was not, sorry. This was the, combined data. Is this the one? No. Just 1 second, because, they removed this. Sorry, they have in different components now. It's been a while, so this is what I wanted. So let's say we want, I will copy paste this line component 3 times. If I want to align this, I select them and I press this button. If I want to distribute equally, so for example, if I have this and I want to be like really organized, I just press this and you have the same distance between components. So let's do this here. Let's plug this guy here. Let's plug this guy here, this guy here, this one here, and this one here. So basically what I did, I have 3 examples to show you what is the difference between the different type of relating the data between two lists. So I will, if I select this, and if I right click or shift space, no, control space, yeah, now they did control space to show the menu. It used to be just space. In Rhino 5 they changed it. I don't know why, because it was really cool just to have the space bar to display this radial menu. So for example, if I select these 2 components and if I press control and space, you will have like quick links. So for example, remember group, you have it here. Now also you have this bake that Axel showed in the studio session on Wednesday. You have bake also integrated here. You have like many options. You can basically check those by yourself. So, but we have also like disable preview and enable preview. So now if I enable, I will show what's going on with these nodes. But if I press this, this will turn into a dark gray. That means that they are not being visualized or can't be visualized, because basically this is just data managed. I'm just working with data, I'm not creating data. There's nothing to visualize. So basically when these are dark gray, it means that they are not being visualized. So basically this is the shortest list, right? This is a way of relating two lists. See what happens here. First with first, second with second, and when it comes to the 6th point, point number 6, connect this, and it says, because this is the shortest list, basically I don't create connections. I will not create connections between this list and this list. It doesn't matter if I have remaining items that are not connected. On the other hand, you saw cross-reference. If I enable the preview on, sorry, not the preview on this one, because there's nothing to visualize. If I turn off the preview on this one, turn off and turn on the preview on this one, I can have like different types of cross-reference. So basically what this is doing is connecting the first point of this list to all of the points, all of the 6 points of the second list, and is doing the same with basically the second point, the third point, and so on. So basically this is why you have all of this like really visually appealing result, and you can play with like different types of cross-reference, like a diagonal, coincident, that I don't know what is it, lower triangle. Basically you can explore the possibilities. Very cool. So this is creating, see, like 51 lines. This was creating only 6 lines. And if we go to the last one, hit preview, you have the one that happens by default, which is the longest list. By default, Grasshopper will always try to match the remaining items from your list to the second one. That is also like really cool. But it's good that you understand this, because sometimes this happens, like when people say like, oh, how can I basically work like this? Basically, how can I match my first list to the second list? That's cool. We're gonna keep working with this guy over here. So basically, because this happens by default, we will leave this guy here. Maybe I should keep it so you visualize samples. These are just like data examples. So we will start working from here. So now another way of working with elements inside Grasshopper is that you have list manipulation, and this will happen in sets and here. So let's say, for example, and we will return to the reparameterize thing that we saw earlier in this tutorial. Let's say we want to create a point that will be located in this line, right? So we can go to curve analysis, and we have different options to do this. One option will be evaluate curve. We have it here, and the other one will be point on curve. There are some differences, and the main difference is what you get from this function. So for example, if I connect this is a slider. Basically this will give you as an output a list of points. One list of points. Okay, And basically, if you move this to 0, you move this to 1, you will change the location of this point. That's pretty cool. Basically, here you can also establish, I want a point to 1/4 of the line, I want this on 2/3 of the line, and so on. If we do this here, I will turn off this visualization, preview off. If I do this, basically, if I connect this line to the curve input parameter, nothing happens. First, because we need another parameter. This doesn't always happen, but basically, you saw it here when we divided the curves. We don't need this number connected because it already has data internalized inside the node. Here, basically, you see that if I put the mouse over the small caps T parameter, I don't have data internalized. So I need to provide this. So let's say I will put 1.0, and I will connect this, and now I have a slider that goes from 0 to 1, right? Basically, you can create the same thing. By default, this curve is reparameterized, so I will do something to show you the difference. I will create this curve like, let's say like this. I will call it from Rhino, set one curve. I will copy this component, and I will replace the curve here. So see what happens. I am the 0, 0, right, T parameter. If I go to 1, something weird is going on, right? Here I'm at 0, here I am at 1, and I go to the end of the line. Why? This is not happening here. Basically, because this is a more complex curve. If I want to express the T parameter in terms of 0 and 1, I need to reparameterize it. So if I do this, now you see I can go from 0% of the domain of the curve to the 100% of the curve. So I'm showing you this because this is something that might happen. So I will erase this. I hope you understand this example. If not, just rewind the video and you will understand. Now, for now, we will keep using the more complex one. Right now, we get, oh, actually, let me go back to the curve parameter, because also you will understand one thing. The difference between this guy, that is just a slider that plots a point, with this and with this. Here in this component, which is more powerful, we are not only getting the point, basically a vector, a position in Cartesian space, we are getting also the tangent of this point. So you see the tangent here is this vector, right? I will show you how to draw the tangent also now. And you're getting this, that is the angle in radians of incoming versus outgoing curve. In this case it's 0, and it never changes. I don't know why. It doesn't matter. Basically you have 3 parameters. Sometimes you will get this parameter here. If you want to draw the tangent, for example, I will go to curve, and I will go to line SDL. Basically, this is a line not defined between 2 points, but it's defined by a starting point, by a direction that basically is a vector, and here we get the tangent, and also by a dimension. So we can say that this is 5.0, for example, connected here, and I'm getting the tangent line at this T parameter. So you can see it's like this is traveling along the curve. This is also quite interesting if you want to do it. Pretty cool. I will leave this here, and maybe I can post this example. I mean, this is really basic, but I can post it maybe to the Slack group or send it by email. So we will stay with the more complex one. Sometimes you just want the other one because you just want a point on a curve, but that's fine. We will work with this guy here. I will hide this and maybe also disable the visualization of this set of nodes. That's fine. You see, right now I don't have any indication of what this is doing. If you do what we did with the group and put in the name, it will help us to help you to understand what is going on. Because at some point probably you will not be able to understand or describe what is going on, and for us we will lose like most of the time trying to decipher what you're doing. In this purpose, just we will just do it like this. So now we have basically this set of points, right? What if I want to connect, for example, this line to each of these points, right? Basically like this point to each of these points to create a line from here to here, from here to here, from here to here. We know that those points, basically the point which I'm talking about is the 0 element of this line. Assuming that this is the 0, maybe this is the 0. We'll check immediately. If I want to do that, how do I extract, or basically how do I call that specific element? There's no way. It's trapped in a list, right? Well, Grasshopper gives you a set of operations with lists where you can basically get this item. So the most popular node here is list item. So I will put this here, list item, and I will make a connection from this node to this node. And in fact, it is the first element. So basically now you will see that the input parameters first is your list. Then you need to indicate the input of the index, sorry, of this of the element that you want to get. And basically this is wrap index to list bound. Basically this is a little bit more complex. I will not explain it now. So let's say I want one specific element. Because I know that these are 11 elements, I can create a slider, for example, from integer slider, and connect it here. So see what happens now. I have a slider connected to the index parameter, and if I move this slider, see how the green point changes position, because basically with this slider I'm calling always a different element. So I want this point, and now from this point I want to draw a line, remember, from point A to point B, and voila, this is what happens, right? First point to all the other points, and I'm getting this new configuration. But if I change, because this is parametric, if I change, see, the point that I'm calling with this function, I change the position. That is actually pretty cool, right? Because I'm getting always a different point, and I'm getting this line. So I think we're gonna leave this tutorial up to here. I mean, we will check as soon as we do like more concrete examples how to work with these other really powerful functions to, I don't know, reverse a list, or do like basically dispatch a list according to a predefined condition. One thing that I forgot, and basically this will be the end of this tutorial, you said that, oh, do I need all the time, if I want, for example, another item, do I need to do, basically create another a set of this function and a slider to get another element? Sometimes yes. In this case, so for example, I create another line and I'm connecting the second element of the list. So basically I have another set of lines. But sometimes if you, for example, you want consecutive elements, if you zoom in to the node, you will see this plus sign. So here you get I, which is the index, plus 1. So that is the same of saying get the next element. So now if you play with this slider, you will always get this. One element and the following one. Or I minus 1. But this is tricky, right? Probably you know why. I will create a line with the element before. So you see these are the lines with the original point that I'm selecting directly with this slider. But what happens when I go to, you see, if I go to element 0, instead of retrieving an error for this set of lines, this goes to the last item. So basically it's like a loop type of thing. So if I do, for example, this is a Boolean parameter. If I don't wrap the index, so basically this will happen. I will repeat the set of lines. No, basically I will get null elements. This is, you see, this is not showing me that this is an error. This is just showing me that this is creating null elements, and that is tricky because sometimes it can create confusion. So be careful when you use this. Sometimes it's better just to repeat this and get elements separately. So yeah, try to play a little bit with this. The next tutorial we will see how to work with surfaces. Thank you very much.